All right. Hi, class. Welcome back. In this lesson, we're going to look at radicals, okay? Radicals are basically operations that we can do to find um, like the opposite of squaring or cubing or exponents, okay? Let me explain. So right here, we have this symbol, this radical symbol. And we have 4 different types. We can have like a lot more than 4, but for now we'll look at these 4. In Algebra 1, we'll look at mainly square roots and cube roots, but you can go higher with higher roots. Anyway, square root. So this symbol, this has this radical, and technically that there is a 2 up here, but we don't write it, but that square root means you're looking for a number. Let's just call that number A, okay? You're thinking about a number, when you square it, gives you this 25. Well, that's 5, right? Because 5 squared is 25. So the answer to this question, square root of 25, is 5. And Desmos knows that as well. So like if you put square root, it's down here. Square root of 25 is 5. That's the square root. Cube root, same type of things, where we're thinking about a number, let's just call it A, that when you cube it, gives you 27. So what number times itself 3 times gives you 27? That's what a cube root talks about. Well, the cube root of 27 is going to be 3, because look, 3 to the power of 3 is 27. 3 times 3 times 3 is 27. Okay? And to find if you want to just put it in Desmos, so wait, hold on, let me write the answer here. This would be cube root of 27 is 3. So you can find that here in functions. And then you're going to scroll down, all the way down. You're going to do nth root. N means you can put any root that you want. You can put a square root, cube root, 4th root, 5th root, and so on. So here I'm going to write the cube root, 3. Cube root of 27, it'll give you is 3. Okay? And then you have 4th roots and 5th roots, but I'm not going to talk about those, but it's the same concept. You're thinking about a number to the 4th power that gives you 64. So that's 2, because 2 times 2 times 2 times 2, 4 times is 64. You don't have to worry about all that. For this, for Algebra 1, we're going to think about square roots and cube roots. Most of it can be done in Desmos, but there'll be times where you do have to do it by hand. Okay, so we have perfect squares. This is a very, very important concept here. Perfect squares and likewise perfect cubes, which means that the number underneath your radical is a number that'll give you a perfect number here, meaning they won't be decimals, okay? For example, like square root of 4 is 2. But if I do like square root of 5 is not a perfect square because I get a decimal, okay? But we need to know how to deal with things that are not perfect square, and I'll show you how to do that. But for that, you do need to get familiarized with your perfect squares here. Square root of 4, square root of 9, 16 is a perfect square because 4 times 4 is 16. 100 is a perfect square because 10 times 10 is 100, and so on. Okay, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and obviously the list keeps going on. And perfect cubes, honestly, I don't have these memorized, so I'm going to depend on Desmos, but if you're good at memorizing, you can memorize those as well. It's very helpful. So like we can go ahead and look at these. Let's just quickly do these. You can throw all these in Desmos, or square root of 81 is 9. Square root of 81 is 9. Square root of 64, you have to just be careful. Is it asking for square root or cube root? Okay, square root of 64 is 8, because 8 times 8 is 64. Okay. Cube root of 27 is 3. Cube root of 27 is 3. Cube root of 216 is 6, and then so on. I'm not going to go, well, actually, cube root of 64 is 4. Now, what about, this is important right here. What about if you have a negative? First of all, if you have a negative under a square root, it's undefined. You can't take the square roots of negative numbers. You won't see those problems. But you might see a problem with cube roots of negative numbers. You can take the cube roots of negative numbers. So the way that works is the answer will have the negative come out of the radical. And then 512 is, cube root of 512 is negative 8. Okay? You can do that in decimals as well. So remember, you go to functions, you go all the way down here, cube root of negative, what was it, 512 is negative 8. The negative always comes out of the radical of cube roots. All right, and then something like this here is the same thing. It's just basically doing cube root of 9, sorry, square root of 9 over square root of 100. So that's going to be 3 over 10. Okay, same thing here. You can do the same thing in decimals. You can do square root of 9 divided by 100. You will get a decimal, but turn it back into a fraction. So that's 3 over 10. Same thing with cube root. Cube root of 1 over 8, that would be 1/2. So this is the same thing as saying cube root of 1 over cube root of 8. Cube root of 1 is 1 over cube root of 8 is 2, because 2 times 2 times 2 is 8. I have it right here as well. Okay. All right, so that's just a little introduction on cube roots and square roots. Now, we're going to talk about what do you do when you take non-perfect square roots. So basically, when you put it in decimals, you don't get a perfect square. So square root of 48 is, excuse me, not a perfect square. So these are the main type of problems that we're going to learn to deal with in Algebra 1. All right, so the way it works is we like to take out as many perfect squares that is inside that are factors of 24. Factors means two numbers, however many numbers multiplied together get you this number. So you know that the factors of 24, I'm going to explain it real quick, and then I'll show you a very quick, easy way in decimals you can do this, okay? But anyway, but the concept here is, think of numbers that multiply together that give you 24. So we know that off the top of my head, I know 2 times 12 gives you 24. Yeah, but if you notice, square root of 2 is not a perfect square. That's nowhere to be found here. And then square root of 12 is not a perfect square. So these two numbers don't work. What other numbers give you 24? 6 times 4. 6 times 4 is 24 as well. Now, if you notice, 6 is not a perfect square, but 4 is a perfect square. So the way you can think about square root of 24 is you can either write square root of 6 times square root of 4. So square root of 6 is not a perfect square, so I'm going to leave that under the radical. But square root of 4 is 2, so I'm just going to leave this as square root of 6. And I'm going to do square root of 4 is 2. The radical goes away. So to write this all nice and neat, you're just going to write 2 square root of 6. And that's my answer. That's what my answer is going to look like. Okay. Let's do a couple more of these. And then I'll show you the easy way in decimals, okay? All right, so 48. We have to think about two numbers that multiply together that give you 48, but I want to make sure that I get a perfect square out. Now, there'll be situations where you'll have more than one perfect square that could go into 48, okay? But you want to make sure to get the highest one. So what I like to do is I like to put 48 and I try to think about, and I'm going to just hit divide and then start dividing by some perfect squares to see if any one of them go into it. So for example, right here, 49 is not going to go into it. So 49 is a perfect square. That's not going to go into it. Let's see. Let me take out 49. I'm just dividing some of these square roots. Let's try 36. Doesn't go into it. Let's try 25. Doesn't go into it. When I say doesn't go into it, I mean that it's like it's giving me a decimal. So it's not divisible. There you go. That works, right? So we can say that that means that this is 16 times 3 gives you that 48 that I'm looking for. So I can say square root of 16 times square root of 3 equals 48. So these two are equivalent. And then square root of 16 is 4, right? So 4 square root of 3 is my final answer. And if you want to check, like if you did it right, you can do a quick check by putting everything back in. So square root of 48 gives you this. And then 4 square root of 3 gives you the same answer. That's another way you can go ahead and check your answers, okay? So I'll do one more for 72. So 72 divided by 81 is already too big. So like 64, nope, 36. That worked, okay? So that means that square root of 72 is the same thing as 36 times square root of 2. 36 times 2 is 72. 30 square root of 36 is 6 square root of 2. And that's it. Okay. Always start from the bottom and go up so that you're finding the largest perfect square that goes into it. All right. So that's that. Now, if you want to do this a little bit faster in Desmos, this is how you could do it. Now, you have to know that your final answer has two numbers, right? It has a number on the outside and then a number on the inside. You're trying to get those two numbers. A way you can do it, like foolproof way, like this will always work in Desmos is, but you have to remember the steps here, okay? So I don't know where to write it. I'll write it here in Desmos. Let me write it in a different color so you can catch your eyes. So in Desmos, there's a little trick you can do. You can do the number. So I'll just call it A, the number. So like basically you're trying to find the square root of A, okay? You take that number and you divide it by x squared, and then you're going to turn it into a table of values, okay? So you're going to do, for our example that we have for number 1, 48 divided by x squared, and then turn that into a fraction. Did I say fraction? I don't know why I said fraction. Turn it into a table. Let me show you again. You do the number divided by x squared. Press the fraction, press the gear button, and then turn it into a table. And then you're going to click on the last number, which is going to be usually 2, and then just press enter. I like to hear this sound whenever I see students practicing. I like to hear that because I know that means you're doing it right. Anyway, and then until you get to zeros here, and then you go bottom up, 4 and 3. The 4 is the number that goes on the outside right here, and then 3 is the number that goes on the inside. That's a quick way using Desmos to find that number that goes on the outside of your radical and the inside. That's your answer. Same thing for 72. Look, I'm going to do 72 divided by x squared. Turn it into a table. Press on the last button. Enter, enter, enter till you get to the zeros. And then you go up, and then there you go. 6 square root of 2. That's my answer. Excuse me. All right, let's do 63. 63 divided by x squared. Turn it into a table. Click on the last number, enter, 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 and then go up 3 square root of 7. 3 square root of 7, and that's it. Now, you will have times where you already have a number on the outside, but what you're going to do is you're going to do the same process, but you're only going to focus on this part first, okay? So, and then the 2 on the outside, the number on the outside, you're just going to leave it alone for a little bit, and then we'll deal with it, okay? So what I'm going to do is I'm going to leave the number alone for now. Let's deal with square root of 90. So we're going to do 90 divided by x squared. Turn it into a table. Hit enter, 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 enter until you get to the zeros, and then you go up 3 square root of 10. So the 90 is going to be 3 square root of 10. And then the 2 stays, right? The 2 comes down, and then the 90 becomes the 3 square root of 10. And then now you're just going to combine the 2 and 3. So 2 multiplied by 3 is 6 square root of 10. And there you go. That's my answer. Okay. So same thing here. I'm going to leave the number 3 out here alone. And then I'm going to do 175 divided by x squared. Turn it into a table. Click on the last button. Enter, enter, enter. Enter, enter, enter till you get to the zeros, okay? And then you go up 5 square root of 7. So 3 multiplied by 5 square root of 7. 3 times 5 is 15 square root of 7. Okay, and then the negative 3, leave that alone. 10 divided by x squared. Turn it into a fraction. Enter, enter, enter. And then you're gonna say, so look at this one. So this one has a 1. So if you were to keep with the process, this is 1 square root of 10. What that means is square root of 10, I cannot simplify it. It's already in simplest form. So guess what? This one, there's nothing I can do about it. This is already in simplest form. To the end, there's nothing you can do. You don't have to write any of this actually. So when you see something like this, you can either say already in simplest form. I don't know why my pen is giving up on me. You can just say simplest form, and that's it, okay? So let me quickly show you the same process for cube roots now, okay? Excuse me. Same process, okay? Except when you're doing cube roots, okay, when you see the 3 up top, the process changes a little bit. So I'll go ahead and write the Desmos part right here. So in Desmos, what you're going to do here is you're going to write 40 divided by x cubed. Whereas in the previous example, if it's square roots, you're going to put, in Desmos, you're going to write 275 divided by x squared. You see the difference? Because this is a cube root, you're going to put x cubed. And then since this is a square root, you're going to put x squared. And then find your answers. Okay, so I'm going to do these 2 problems. So I'm going to do 40 divided by x cubed. Turn it into a table. Enter, enter, enter. Start from the bottom. 2 cube root of 5. So this ends up being 2 on the outside, and then the number on the inside is cube root of 5. And that's my answer. Whereas the square root of 275 will be 275 divided by x squared here. turn that into a fraction, and then you're going to hit enter, 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 and then you have 5 square root of 11 here. So you have 5 square root of 11 here. Okay. And then the only other thing I'll show you is like these two problems, number 12 and number 15. Number 12 has the negative on the outside, and then number 15 has a negative on the inside. So for this one, remember, we're going to leave the number on the outside alone. We're not going to do anything with that yet. Let's go ahead and deal with cube root of 432. So we're going to do 432 divided by x cubed. I'm pressing this button to go up there for the exponent. And then table, enter, 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 go up 6 cube root of 2. So you're going to do times, you have your 6 cube root of 2, and then you just multiply these two numbers. Negative 2 times 6 is negative 12 cube root of 2. That's my final answer. All right, number 15, we're going to do 4 cube root of negative 18. So you have 4 times, what I want to tell you, well, okay, I don't want to confuse you, but there is something a little bit, you have to be careful here. So you have 88 divided by x to the power of 3, and then to that, 2 square root of 11. Now, oh, I forgot to put the negative. My bad. Negative 88 divided by x cubed. The thing here is, whenever you do this, it leaves the negative in my radical, but you have to remember to always take it out. So if you just see a negative under a cube root, just take it out and then deal with the positive. Okay, so like basically what I'm trying to say here is this ends up being negative 4 cube root of 88. Okay, just take out the negative first, deal with the negative first, and then go ahead and do it. Okay, or else it gets a little confusing. So 88 divided by x cubed. Okay, and then you have your 2 cube root of 11. I'm doing this one, 2 cube root of 11. And then you have negative 8 times 2, negative 4 times 2, which is negative 8. And then cube root of 11. Okay, that's how we deal with it. Just pay attention to cube roots and square roots. I'll go ahead and I do have I'll go ahead and stop the video here. We have a couple more lessons with dealing with problems with radicals, but I'll stop here. I'll post the answer key up on Schoology as well, and I'll have you guys take a look, practice. Thanks, guys.